Hello everyone, my name is Pavitra Vyas from Department of Information Science and Engineering, Sri Venkateshwara College of Engineering. Today I'm going to explain about a topic called Intelligent Storage System. Intelligent Storage System. What is Intelligent Storage System? An intelligent storage system is a data storage system that incorporates a layer of software for analysis and processing. This allows the storage to actively optimize application, network, and workload performance. Components of an intelligent storage system. Intelligent storage systems are feature-rich RAID arrays that provide highly optimized input-output processing capabilities. These storage systems are configured with a large amount of memory called cache and multiple input-output paths, and they use sophisticated algorithms to meet the requirements of performance-sensitive applications. An intelligent storage system consists of four key components. They are front-end, cache, back-end, and the last one is physical devices. This is a diagram which represents the components of a intelligent storage system, wherein we can see the front end, the first component, the second component is cache, the third component is backend, and the last one is physical disks. Front end. The front end provides the interface between the storage system and the host. It consists of two components, front end controllers. A front end has redundant controllers for high availability, and each controller contains multiple front end ports that enable large number of hosts to connect to the intelligent storage system. Each front-end controller has processing logic that executes the appropriate transport protocol such as Fibre Channel, ISCSI, FICON, or FCOE for storage connections. Front-end controllers route the data to and from cache via the internal data bus. When the cache receives the right data, the controller sends an acknowledgement message back to the host. Second component, that is cache. Cache is semiconductor memory where data is placed temporarily to reduce the time which is required to service input-output requests from the host. Cache improves storage system performance by isolating hosts from the mechanical delays which is associated with rotating disks or hard disk drives. Rotating disks are the slowest component of an intelligent storage system. Data access on rotating disks usually takes several milliseconds because of seek time and rotational latency. Accessing data from cache is fast, and it is typically takes less than a millisecond. On intelligent arrays, write data is first placed in cache and then it is written to the disk. Structure of cache. Cache is organized into pages, which is the smallest unit of cache allocation. The size of a cache page is configured according to the application input-output size. Cache consists of the data store and tag RAM. The data store holds the data, whereas the tag RAM tracks the location of the data in the data store and in the disk. Entries in tag RAM indicate where data is found in cache and where the data belongs on the disk. Tag RAM includes a dirty bit flag which indicates whether the data in cache has been committed to the disk. It also contains time-based information such as the time of last access, which is used to identify cached information that has not been accessed for a long period and may be freed up. Backend. This is the third component. The backend provides an interface between cache and the physical disks. It consists of two components. The first one is back-end ports and the second one is back-end controllers. The back-end controllers data transfers between cache and the physical disks. From cache, data is sent to the back-end and then routed to the destination disk. Physical disks are connected to ports on the back end. The back-end controller communicates with the disks when performing reads and writes and also provides additional but limited temporary data storage. The algorithms which is implemented on back-end controllers provide error detection and correction and also rate functionality. For high data protection and high availability, storage systems are conferred dual controllers with multiple ports. Fourth component is physical disk. A physical disk stores data persistently. Physical disks are connected to the back-end storage controller and it provides persistent data storage. Modern intelligent storage systems provide support to a variety of disk drives with different speeds and types such as FC, SATA, SAS, and flash drives. They also support the use of a mix of flash, FC, or SATA within the same array. Types of intelligent storage system. An intelligent storage system is divided into the following two categories. The first one is high-end storage systems and the second one is mid-range storage systems. High-end storage systems have been implemented with active configuration, whereas mid-range storage systems have been implemented with active passive configuration. The distinctions between these two implementations are becoming increasingly insignificant. High-end storage system. High-end storage systems, referred to as active-active arrays, are generally aimed at large enterprises for centralizing corporate data. These arrays are designed with a large number of controllers and cache memory. An active-active array implies that the host can perform input-output to its LUNs across any of the available paths. The above figure shows the active-active configuration, wherein here we can see the active and the active configuration. Advantages of this configuration is large storage capacity. It has large amount of cache to service host input-output optimally. Fault-tolerance architecture to improve data availability, connectivity to mainframe computers and open system hosts, availability of multiple front-end ports and interface protocols to serve a large number of hosts, availability of multiple back-end fiber channel or SCSI RAID controllers to manage disk processing, scalability to support increased connectivity performance and storage capacity requirements, ability to handle large amount of concurrent input-output from a number of servers and applications, support for array-based local and remote replication. Second one is mid-range storage system. Mid-range storage systems are also referred to as active-passive arrays and they are best suited for small and medium-sized enterprises. They also provide optimal storage solutions at a lower cost. In an active-passive array, a host can perform input-output to a LUN only through the paths to the owning control of that LUN. These paths are called active paths. The other paths are passive with respect to this LUN. As shown in the figure, the host can perform reads and writes to the LUN only through the path to controller A, as controller A is the owner of that LUN. The path to controller B remains passive and no input-output activity is performed through this path. Mid-range storage systems are typically designed with two controllers, each of which contains host interfaces, cache, RAID controllers, and disk drive interfaces. Mid-range arrays are designed to meet the requirements of small and medium enterprise applications. Therefore, they host less storage capacity and storage than high-end storage arrays. There are also fewer front-end ports for connection to hosts, but they ensure high redundancy and high performance for applications with predictable workloads. They also support array-based local and remote applications. Here I complete with my topic. Thank you. Have a nice day.